Okay, we're doing number 5 now, and we have to carry out this multiplication. And so what this corresponds to is 2.2 times 6.5, because it's all multiplication, times 10 to the 5th times 10 to the 8th. Multiplication's commutative, so we can move the factors around. And when we multiply 2.2 times 6.5, we get 14.3, and now times 10, and we add these exponents, and that should be a 10 here, not an 8, a 10. Good. And so we get to the 13th, so that's going to equal, in terms of scientific notation, we have one decimal to the left, or one digit to the left of the decimal, 1.43. So since we made this number smaller by a factor of 10, we have to make this larger by a factor of 10, so 10 to the 14th, and we're done. And now let's do 6. And we're dividing. Let's see, it says divide 5.11 times 10 to the 12th by 1.4 times 10 to the 5th. Well, there's a couple ways to go on this, and one way is we can leave the factors of 10 as they are, and we'll move this. If we move this decimal over twice, I'll get 511. And if we move, then we have to move this decimal over twice. And so now this still remains 10 to the 12th and times 10 to the 5th. We could have moved the decimals and just adjusted with the exponent on the 10, but I chose to do it this way. Anyhow, when you carry out the long division for 511 divided by 140, I get 3.65. And now this is going to be times 10 to the 12th, and we'll move this factor of 10 that's downstairs upstairs, so that will be 10 to the negative 5th. And so we get 3.65 times 10, and when we add exponents, 12 minus 5 is 7. And we're done with that one. Okay, how are we doing? Good, we have time for another one. Let's do 7. So 7. And let's see. The distance from the Earth to the Sun is 1.5 times 10 to the 8th kilometers. And the distance from the Earth to the Moon is 3.8 times 10 to the 5th kilometers. And we need to find out, now, on a scale model, the distance from the Earth to the Sun is 100 meters. Let's double check that. Earth to Sun, 100 meters, yeah. So I'm going to set up a ratio, because they want to know what the distance from the Earth to the Moon will be on this scale model. So I don't know, so I'll call it Earth to Moon. And that on the model, the Earth to Sun is 100. So equals, and now we'll, let's see, Earth to the Moon is 3.8 times 10 to the 5th kilometers. And by the way, that was 100 meters, wasn't it? 100 meters, yeah, meters. Okay, and the Earth to the Sun ratio value is 1.5 times 10 to the 8th kilometers. Now the kilometers divide out. We don't have to worry about those. And we'll multiply both sides by 100 meters. 100 meters. And now these divide out here, and we get Earth to Moon equals, and the quotient of 3.8 divided by 1.5 is, in fact, I'll write that out, 3.8 divided by 1.5 times 10 to the 5th. Now I'll move this factor of 10 upstairs, so that'll be 10 to the negative 8, change the sign on that. And 100 is the same as times 10 squared to the second. And now this quotient, 3.8 divided by 1.5, turns out to be 2.53, and that's repeating, times 10 to the 5 plus 2 is 7 minus 8 is negative 1. So I'm going to round that, and that'll be 2.53 times 10 to the negative 1. And they want scientific notation for that. And if we weren't using scientific notation, that would equal 0.253. And those are meters, by the way. Meters, meters, and meters. So either one of these will work. Let's go on to the next one.